Hey guys, Darren Giuseppe here, back again with another video for the Key Concept series. What we're going to look at today is the last topic in complex numbers. That topic is the locus of a complex number. So the locus of a complex number. The first thing we need to look at is what is the locus. And the locus or a locus is a set of points that satisfy a given condition. So let's consider a complex number z is equal to x plus iy. Let me do that first. And just drop a little argon diagram here with no plots, nothing, just the axes. If we look at z is equal to x plus iy, that could be anywhere here, anywhere, like anywhere, because x is any real number, y is any real number, right? But if we now apply or put a condition on it, where we say the modulus of z is equal to 3. If we say the modulus of z is equal to 3, we impose that condition. What will we get? What it's saying is that the modulus of z is equal to 3. So the length of the complex number is 3. But remember, z could be any number here. So we want all the set of numbers that are they are 3 units in length. All the complex numbers that are 3 units in length. And well, they would have to start from the origin and come here, start from the origin, come here. It would be an infinite set of numbers, but all the lengths must be equal to 3. When you do that, this is what you would get here. You would get a circle with center 0, radius 3. So we said that the locus is a set of points that satisfy a given condition. The set of points in this case, or the locus of this complex number here, z modulus of z is equal to 3. The locus is actually the circle. The locus is the circle, right? Radius 3, center 0. That is the locus. So remember, we said z is equal to x plus iy. So it's all the values of x plus iy that would, when you find the length of them, it gives you 3. It gives you a length of 3. So all the complex numbers that give you a length of 3, right? When they are joined with the origin, so this complex number here, it will be an infinite set of complex numbers. All those complex numbers that when you join them to the origin and they give you a length of 3, those complex numbers, all of them combined together, right, would combine to give you the set of points that satisfy the condition. And the condition is the length of the complex numbers of those complex numbers is equal to 3. So that is basically the locus, and that's what it is. What we have to know for our exam or for Pure Maths Unit 2 is 4 particular locus, right? We have to learn 4. We have to know the general form, how the locus would be, and then describe it, and also they could ask you to sketch it as well. So that is what we want to look at next. So we need to describe and sketch the locus where, and this is, I just put this in a table form so it would be easier to just look at. So we need to look at the locus, which would be, right, the set of conditions or the set of points, right, on that given condition. And we need to look at the description of it and the sketch. So the first one we look at is the modulus of z minus c is equal to r, where c is a complex number and r is a real number. That is similar to the one that we just now looked at, right? But in our case, c is 0, right? So, and c is the center of the circle. The description for this is a circle, right? The locus of z is a circle, center c, and radius r. And then the sketch, this is just a general sketch of it here. This is what you would have here, right? So the previous one, in the previous question that we did, it was just the modulus of z is equal to r. Your c was basically 0 in this case here, it was actually equal to 3. So your C was actually equal to 0. It was 0, 0, right? So that was similar to this question here. Then the second locus we need to look at is the modulus of Z minus A is equal to the modulus of Z minus B, where A and B are complex numbers. This is the locus of this complex number is the perpendicular bisector of the line joining A and B, perpendicular bisector of the line joining A and B. And a quick sketch of this is here. So the locus, remember, we say that the locus is a set of points, right, that subjected to a particular condition. So in this case here, the locus is this. The locus would be the set of points here. If I draw that kind of thickish, it would be the set of points here, that line there. And in the case of the circle, the locus would be all the points here. They under the condition there. And then we look at the third locus that we need to look at, the argument of Z minus A is equal to theta, where A is a complex number, theta is in radians. That is the locus of Z is a half line starting at A, excluding A, and making an angle of theta radians with the positive real axis. So it's a half line starting at A, but excluding A, and making an angle of theta radians with the positive real axis. So those things very key to note. And then, well, this is your diagram here, your sketch of it, right? Your half line starting at A, but excluding A. So hence why I have a hole, and then this is the line here. This will be a locus there. And finally, we have Z is equal to A plus lambda B, where A and B are elements of the set of complex numbers. Lambda is an element of the set of real numbers. So the description for this is the locus of Z is a line passing through A and parallel to B. Passing through A is the locus and parallel to B. So your general sketch will be this. So the locus is the line passing through A and parallel to B. So let me just do something really quickly here. Your B would be this here, right? This is your point B. So your locus would be this line here. And that is basically it. You want to make sure you be able to identify these and describe them and be able to draw a sketch. That is key. And that is about it. So you want to do that for all three. Make sure you understand them, know them inside out like the back of your hand. Right, guys? That's basically it for this video. Like, subscribe to the channel, share the video to anybody that you think it might help. And guys, we'll be doing plenty questions thereafter we finish this complex numbers in terms of the theory. But now we're going to look at some questions. So I hope these questions help, and see you in the next video.